Assalamu alaikum, my dear students. I hope that you are well by the grace of Almighty and you are taking necessary precautions for the situation of COVID-19. So, uh, today I will introduce you to the chapter of your textbook, that is class 9 English medium. So, I'm the chemistry teacher of English medium day shift of Prajaguttara Model College. Today, the discussion of our topic will be chapter 6, concept of mole and chemical counting. Let's start. So first of all, in this chapter, the first topic will be mole. So what is the definition of a mole? Will be the gram atomic or gram molecular mass of a substance, or it can be the Avogadro number of molecules of a substance, that is 6.02 into 10 to the power 23 molecules, the Avogadro number. So mole basically means the total number of gram atomic or gram molecular mass of a substance, or it can be the Avogadro number of molecules of a substance. For example, you can see here that sodium 1 mole sodium, it will be 23 gram, that is the atomic mass of sodium, and it 1 mole contains 6.02 10 to the power 23 molecules. Basically, 1 mole of a substance, it can be a single atom, it can be a single uh, let me correct here that uh, it's atoms. So these two are the molecules, so I had to correct that. I'm sorry, apologize. So 1 mole sodium, that is 6.02 into 10 to the power 23 atoms, because it's a single atom, and 1 mole chlorine, it's a molecule, so it will be the Avogadro number of molecules, that is 71 gram, and 1 mole of a carbon dioxide, it will be 44 gram of carbon dioxide, that is the Avogadro molecules. So this is the concept of mole. So how can you determine the molecular mass of a substance? So basically, when you see a molecule, you have to determine how many atoms are present individually in the molecule. So first of all, you have to uh, know the atomic mass individually of the atoms, and you have to multiply them by the number of atoms present in the molecule, and you have to finally add all the values. Then you can obtain the molecular mass of a definite substance. So here's an example given, that is 1 mole of calcium chloride. So first of all, you have to uh, write down the atomic mass of calcium, and then you have to add the atomic mass of chlorine, and it should be multiplied by 2 because there are 2 chlorine atoms present. So total it will be 111 gram. So this is the molecular mass of calcium chloride. So by this way, you can determine the molecular mass of a substance. So for any molecules, you can apply this method to determine the definite molecular mass. So let's jump down to the next topic. That is here is a mathematical problem given. So please read the question. That is, what is the mass of one carbon dioxide molecule? This there is you have to determine the mass of only single carbon dioxide molecule. For this, you have to bring down the Avogadro number and the uh, atomic mass, oh sorry, molecular mass of carbon dioxide. So molecular mass of carbon dioxide will be 44 gram. That is the atomic mass of carbon is 12, and atomic mass of carbon oxygen is 16. There are two oxygen atoms present. So by summation, you can obtain the atomic molecular mass of carbon dioxide, that is 44 gram. Then you have to bring down the unitary method to solve this problem. That is, the required value should be at the right side, and the given value should be kept at the left side. So we have to determine the mass of carbon dioxide molecule. So mass will be at the right side, and the molecules number, it will be at the left side. So by this method, you can obtain the molecular the mass of one molecule of carbon dioxide, that is this you can obtain by calculation. You can uh, bring down the scientific calculator of yours and you can check the value. So there is a mathematical problem, and here's another. So it says that how many moles are present in 10 gram water. So 10 gram water, and you are required to determine the number of moles. So you have to also use the unitary method here, and you have to put the mole at the right side, and we all know that 1 mole water contains 18 gram. So 18 gram water contains in 1 mole, and 10 gram contains, according to the question, that is 0.56 mole. So this is the easy mathematical problem, and the you can find this in some internal exams or in board exams or pre-test or test exams. So these are very much easier maths, and you can solve it by with the no-brainer actually. So we have learned the concept of mole, and we have seen some mathematical problems, and then let's jump down to the next topic, that is molar volume of a gas. So the molar volume of a gas, it means the volume occupied by 1 mole of that respective gas under certain temperature and pressure conditions. So certain temperature and pressure conditions, it can be STP, that is standard temperature and pressure, or it can be another in external factors. So it should be described at the question that you have to solve. So at STP the elaboration is a standard temperature and pressure. So the at STP the volume of a gas or a substance is equal to 22.4 liter for 1 mole of a substance, and temperature will be 273 Kelvin, that is 0 degrees Celsius, and the pressure will be 1 atmospheric pressure. So this is the condition of standard temperature and pressure. Please note it down, and you have to memorize these values. So because in so many types of mathematical problems in chapter, you have to face the STP word in so many mathematical problems, so you have to be familiar with that. So number of moles, how to determine the number of moles? There is an equation, that is number of moles, small letter n equals to W by M. So you can determine by this method, that is W by M, or you can determine the molar volume by using the STP volume, that is V divided by 22.4, or you can determine the molar volume, that is number of moles, by uh, N, capital N, divided by 6.023 into 10 to the power 23. So this is the equation for determining the number of moles by using mass, and there is the this is what we have to this is what we need. This is the molar volume formula of a gas. You have to determine the molar volume by using this equation. So here W is the mass of substance given in the respective question, and M, capital M, will be molecular mass, and capital V will be the volume, and capital N will be the number of molecules. So this is the uh, ways of determining the moles by atomic mass, that is mass, or it may be the parameter of volume, it may be the parameter of molecules. So there is a mathematical problem given, that is how many molecules are in 1 liter of hydrogen gas at STP. So here we have to determine the number of molecules in 1 liter of hydrogen gas at STP condition. So at STP we have known that 1 mole hydrogen is equal to 22.4 liter of that respective gas, and that Avogadro number of molecules. So by using this unitary method, you can easily determine the uh, number of molecules. by using the STP volume. So the STP factor should be memorized properly so that you can write the definite value here, because in the question the value of STP won't be given. It will be just mentioned and you have to memorize and you have to write write the values according to the question that you have to determine the value. So the mathematical problem is given here, and the next problem will be what is the volume of 10-gram carbon dioxide gas at STP. So there's the mass of substance, that is 10 gram, and molecular mass of carbon dioxide, you can determine that is M and W are given, and by using N equals to W by M you can easily determine the uh, mole number of 10-gram carbon dioxide by using this formula. We have learned this formula 2 slides ago. So this is the example of a mathematical problem. So molar volume of a gas is now clear to us. So we have learned the number of moles and we have learned the molar volume of a gas, how to determine that, and now we will advance to the next topic of ours. So there is a definition that is called molar solution. So what is a molar solution? So please keep in mind you have to write this line, that is at constant temperature. The temperature should be constant. The temperature cannot vary. At constant temperature, if 1 mole of a solute is dissolved in 1 liter solution, then it is called a molar solution. So it's involved in 1 mole of a substance in 1 liter solution. So you have to keep in mind that if 1 mole of a solute is dissolved in 1 liter solution at a fixed temperature, it can be 25 degrees Celsius, it can be 30 degrees Celsius, whatever, the temperature should be constant, then the solution will be called molar solution. So 1 mole of a solute will be dissolved in 1 liter solution, it will be called molar solution. Now the important, one of the most important topic in this chapter is molarity. So the definition is given here. Molarity will be the amount of moles of solute required for preparing 1 liter solution at constant temperature. So the amount of moles needed to prepare 1 liter solution at constant temperature is called molarity. So molarity is basically the moles required per 1 liter, moles required per 1 liter for a solute. So unit should be mole per liter, that is moles required per liter, or it at a specific word the unit is molar and it's expressed in capital M. So capital M, we can just write down the unit that is capital M, or we can write the unit that is mole per liter, whatever you like. So there is the formula, that is capital S molarity. The capital S equals to W into 1000 divided by M into V. Here W is the mass of substance expressed in grams, and the molecular mass of substance is also in gram, and the volume of solution is in milliliter. Please keep in mind that the volume of the solution will be given at the question in milliliter. So this is the formula of molarity. Now let's see some examples. So determine molarity of 10 gram sodium carbonate for 250 ml solution. So here we can see that W is given, and we can determine M, that is molecular mass of sodium carbonate, by calculating the atomic masses, and the V is given here. So W, M and V, they are given. So now we'll just use the equation and put down the values. Then we have to use the calculator, and you can easily obtain the molarity, that is 0.337 molar. So it's pretty easy if you understand, you can understand this properly. It should be very much easier for you. So these are easy topics, and that is all for today. The next part will be uploaded 2 or 3 days later, so please keep checking the website of our college. Please stay updated and stay safe, and we'll uh, discuss the next topics later. So till now, stay safe and please use the masks and please uh, maintain the safety protocols for COVID-19. So that's all for today. Uh, so take care of us.